All right. Well, with that, again, we have a very cool presentation today. Xin from MediaTek will be presenting on MPEG, as well is well known for its video audio compression codecs, and has also developed an impressive portfolio of standards and technologies related to metaverse and digital asset management. In particular, they've created an industry worth several hundreds billions of USD and helped the industry offer end users an even more enjoyable digital media experience. This presentation provides a brief overview of some of the MPEG standards, and it will be followed by a demo of Elacity, a showcase of a blockchain-based multimedia platform for content distribution, with intent to offer some lessons learned and help our working group produce our deliverables. With that, I'm going to pass it over to Xin.
Okay, thanks for giving the opportunity to make a presentation on MPEG standards, and it has been a good experience to listen to other sessions presentations. I just particularly miss the Leonardo one from MPAI, because he was the convener of MPEG for many years. Without him, and many of the standards I'm going to talk about today, without his support and endorsement, and I'd like to say a special thanks to him. And also, I'd like to make clear this is not an official presentation from MPEG. It's just talking about my personal experience, and because my involvement at MPEG. All right, just want to make that clear. So, I mean, today I'll just go through some of them, but mainly the ones that relate to Metaverse, and especially some of them particularly relate to this group, digital asset management, because I personally involve those in particular. And then I would like to introduce Elacity to give a showcase demo from Sasha Mitchell on the blockchain-based multimedia platform for content distribution. Okay, because you know, there are too many standards, and it's hard for me to go through in any depth. But if anyone is interested in particular standards, and we can talk about offline, or maybe have a separate discussion. Okay, so who is MPEG? MPEG, the full name of MPEG is Moving Picture Experts Group. Officially, it is ISO/IEC organization under JTC1, IC 29. MPEG has a number of working groups under 29, pretty much except the WG1, which is about the JPEG, and all the other groups are under the name of MPEG. Okay, MPEG used to be a single working group. Recently, we spent to the many separate working groups. So the ones that I'm going to talk about mainly are the MPEG system standards, related standards. Okay, so MPEG is basically about a coded representation of a digital audio, video, 3D graphics. Lately, we added haptics and also genomic data. Okay, essentially anything that related to compression, the MPEG is interested. In order to support the consumption or delivery of those data, and then we have media system support, and that involves a lot of things. Because we're dealing with moving pictures, and all the data are mainly timed. They change in the temporal domain. So we need to do a lot of synchronization, how to present them, store, transport, the media, security, privacy management to QoE, and how to measure the performance in terms of the matrix. Okay. This give you the picture here, give you the overview of the organization, who is in charge of which working group, and so on. So what MPEG is famous for? I think nowadays you cannot live without using MPEG technologies. Okay, MP3, MP4, the video codec, AVC, HEVC, and so on. Okay. On the system side, and we have MPEG-2 transport, the ISO-based media file format, and the streaming format dash, and so on. So we have a number of Emmy Awards. If you look through, mainly are system related, how to store, how to deliver. Definitely there's video codec, ABC. It's famous. I think they published their standards 20 years ago, exactly this year, I think this year. So that helps. I think all those ones listed here help today's media, content streaming, online streaming dramatically. Okay, because the content that's stored in the file format and streaming the compressed using AVC, still a lot of using AVC, even though we have HEVC, VVC now, streamed using the dash. Okay, and all right, so here is a short list of the standards that relate to efficient coding and the carriage. Those ones are, I highlighted a few, probably I'll just go through them quickly. My main point here is MPEG is developing a lot of formats to encode and also to store the immersive media content. The format and the carriage, encapsulation are nowadays different from the conventional 2D video. Okay, 2D video. That's the things. That's the message I want to get across. So the client and the server architectures that we're going to encode and consume those type of the immersive media content will probably be different. Okay, will become more complex. Okay, I will go through them quickly. Here's a typical one to start with. The omnidirectional media format. So this is basically, if you talk about VR content, and so you look at user can look around in terms of 360 degrees. This is the architecture for that. As you can see, we can have different codings for. Let me get the pointer. See, probably. Okay. So this still rather conventional because OMAP content is going to be projected to plane and encoded as a 2D video, and then delivered in terms of the conventional mechanisms. But the main thing is now it involves the interaction with the user, and because the user is going to move around, with eyes or with a head, and then we're going to keep tracking the view orientations, and then adjust the content to be presented to the user. Okay, so it involves the encapsulation, delivery, And then you have to have a strategy to deal with the movement and then retrieve the relevant portion of the content and to cover where the user is looking at. Okay, so that's that one. And then the next one is immersive media matrix. Here is a client reference model. The thing here is in order to measure the performance and the quality of experience, and there are a few points that we have to observe within the client architecture. Okay, and so that you can get the latency and figure out your buffer buffer status and so on, and see where the user is looking at. And at those points that you collect the data, you probably can measure the quality of the experience. Okay. The next one, excuse me, is what we call the V3C data. It's a volumetric video. Now this kind of a video deals with the content like point cloud and also the latest immersive video content. In terms of the storage part of it, and it has a multiple components. It's not going to be encoded or stored in a single track. It's going to be multiple tracks. Okay, it has to deal with its geometry, attributes, occupancy, and we need to put them into file format and deliver them in a synchronized way, and be able to reconstruct the immersive video at the client side. Okay, it's multiple. It's much more complicated than the single track of video for the 2D ones. Okay, and then we have a part 10 about scene description, and here is a overview of their client architecture. And as you can see, the client needs to have media access functions that involves multiple pipelines, because in the metaverse, anybody can get the content from different places, especially for scene description. The video, audio, resources may come from different locations, and so it needs to have multiple pipelines to access the media content, and then you buffer them, figure out how to synchronize them, and then render and so on, do the presentation. What MPEG is doing for scene description is basically it worked on the extensions to GLTF 2.0, because as MPEG, we provide timed media content in terms of video and audio and other type of content, and we also want to put in the immersive ones that are developed by MPEG. So the things probably will get much more complex, but more interesting. Okay, so those are ones I just basically highlight for coding and the carriage. The next things I want to go through quickly is a set of standards. Most of them I personally involved, and involves the multimedia framework and digital asset and service management. Okay, So it's a long list. I'm not go through most all of them. Let me start with MPEG 21. MPEG 21. MPEG 21 was started like 23 years ago. That's when I joined MPEG to start working on related standards. At that point, MP3 started to become popular. The internet, has enough capacity to deliver media content. So MPEG was start thinking about, okay, what can we define a multimedia framework to enable the use of those new resources, how we're going to characterize them and make sure we have a framework that can support both usage and the transactions of those media content. So that's where we get into a number of things that I think are very interesting. It's going to be interesting to this group. And we did have a things called the digital item. So basically is a structured digital object that had some kind of a representation, identification, and metadata. Of course, it have the resources, things like a video. If you want to describe, for example, you have a video audio, and you have some metadata with that, and then you can put them together, for example, in a file, then that become a digital item. It could be a collection of digital items. And so if we talk about a
lot
stream,
of people don't know this, but the best way to make.
Hello? All right. Okay. Yeah. So at that point, we have some kind of understanding what the digital item is going to be. Okay. So that's, I think, consistent with what we're thinking of in terms of a digital asset. But then next notion is the user, who is going to engage that digital item. So I'm not going to go through this, but basically it's a generic term representing the individual that's going to interact with the digital item. But this is, I think, something that we can to explore further. In nowadays, how we're going to characterize some entities that are going to interact with digital asset. It's probably not going to be individual person, and maybe some digital twin in the metaverse representing a actual person, and so on. But for digital item, we need to have a kind of a declaration, describe how the object, how the things within, or we call the element, related to each other. And then we have the kind of identification, the way we want to identify not just the digital item, but also the things within, and different things within, like the metadata, how you can identify that part of it, for example. Okay. So with digital items, I think next the big thing that I think we worked on that had a lot of impact in the industry, even though the standard itself is not used as it is, but the ideas we implemented, we specified here influence the the whole industry, especially all the current DRM systems. We need to have a way to just put management information within the digital item, and have a right association at the right level to the components or elements within the digital item. But think about a digital item is like a video that to be streamed. It will have a video content, audio, and all of them need to be segmented, right? Timed together in some way within the file format. And then we need to include the protection management information or DRM service information within that item, and then instruct the client to retrieve the license at the right URL, and so on. Okay, so that's basically what this architecture was talked about. Okay. Anyway, but the main thing is this part of it need to be tied together with the digital item, and probably use rights expression language to specify a license, so that we can do some kind of enforcement. Okay. Next thing is the rights expression language. Basically, is a language that specify what kind of rights that the issuer can give to the end user. It has a number of what we call grants, but each grant represents a right that has basically 4 components. At the high level, it's a principal, action, resource, condition. And this was, I called Xerox Park model, because at that time I was working for Xerox. So it deals with basically who, how, or what, and when the rights can be granted or exercised. Okay. So yeah, at that point, we had this diagram to show Alice has the rights to play resource in the November 2003. Okay, that's basically, and this license-based DRM principle is used in all the current DRM systems, and even though each DRM system may have a different format to specify license information. And that's the things that I feel strongly that maybe for Metaverse, we probably need to have a way to standardize this part of it, and so enable the interoperability, for expressing your rights within all the Metaverse systems. Let me quickly go through the next thing I think is related to this group as well. Talking about the adaptation. How we need to manage adaptation or derivation of a digital items, because those things in their life cycle will change. Okay. How they're going to change, and should we be able to have a way to indicate it, a particular way to change it, because nowadays that people talk about how to prevent deep fake content, and we need to figure out when you edit a resource, and how you're going to edit, and do you edit the way that the original author of the content intended to be or some different. So that's the things this part was trying to deal with, and especially talking about the scaling part of it. And you can do the scaling in terms of temporal and spatial, a number of domains, dimensions. Okay, the idea is we need to standardize some of DIA tools to indicate what kind of tools you can use to do adaptation. Also relate to that, I think MPEG has another part called the MPEG M multimedia service platform technical standards. I think I know this diagram probably is blurred, but the thing is, if we want to adapt adaptation either locally or remotely in terms of services, and there are a number of things that need to be involved. So most of them will be an aggregation of a element, kind of elementary services that enable people to do adaptation. I think this part I want to mention this is because MPEG has a systematic approach to identify what kind of services or that will be involved for adaptation and more generally for management. If you go through this table and we put content contract devices element event and the users on one side, and then you look at the possible actions, and then you figure out which one applies to which ones, which combinations make sense for things. Then that will help us to get a overview what are the things we need to deal with in terms of management. Okay. So then the next one is what we call contract expression language. This basically a extension of the rights expression language to deal with the contractual agreements. The issue was at that point, we know the rights expression language was was designed for consumption of or use of the media content, and that's the downstream of the distribution value chain. And what about the upstream and the deal with the provider, deal with the relationship between the provider and the distributor. And that's where we came up with working on this CEL. And so as you can see, the CEL basically takes all those things from the REL as a basic things, a principal, action, resource, condition, memory part, and then make them as a clause. And then you have a different types of clauses, not just the grant that we had in REL. Now you have a duty for expression, for obligation, ban, for prohibition, claim, for making a statement, and the intent for making requests. Okay, so with all the things, you can put them together in a within a what we call them promise. You can promise a set of things like those this type of clauses, and then have a issuer to issue or basically sign that promise, and then you have a probably multiple promises that will give you a contract. The contract can be signed by multiple signers. So, and And also, we can use this language to draft or to modify the contract in terms of a contract life cycles. Okay. I'll probably spend a little bit, talk about this a little bit more in detail. Within this, I just want to make sure within this CEL, we can make statements and we can declare ownership, authenticity, and provenance, make them as a claims. And we can use the grant to express user rights. We can have a duty to, express the obligation. For example, if I have a video created myself, I can allow it to be played and shared. But if you want to use it for any commercial purpose, you need to attribute or remunerate. Okay, and but also in terms of nowadays, probably I don't want my video to be used for AI training, so we can specify a prohibition on that. CL expressions can be embedded or linked from a digital item. And here is an example that probably you can use as a manifest for composite digital asset, making trusted declarations. Okay, I think the CP2A, they, even though they work independently, but they have the same idea on that. Okay, let me go through quickly. The next thing is a media contract ontology. I think this is it's a sister standard of the CEL, but using a different representation, ontological representation. I'm doing on time. Okay, so the next thing is this is the things that we worked on lately. This is also work that was started with the help from Leonardo. We'll talk about the smart contract for media. So how we're going to use our contract standards to enable interoperability for different blockchain systems. Okay, and especially how we're going to help people deal with the issue if you want to go from one chain to another. Then what about their smart contract? Okay, so here, but to start with that, I think, as I said before, we're trying to use CEL REL to support transactions and the usage. Okay, so between two users, and if it goes through those steps, and then we need to engage different blockchains, and also we need to deal with the different DRM systems. And the reality is, we'll have to rely on existing DRM systems to support the consumption of the content. Right now, we come down to a few DRM systems that we tied to different types of operating systems, and we need to rely on the blockchain systems to conduct the transactions. The MPEG contract standards will probably help to do the basically conversions between different smart contracts to enable interoperability. Now, here's basically a diagram for that. I don't think this is hard to understand, but we have a white paper on that to talk about in some level of details. Okay, so it's not hard to imagine how we're going to do this. Essentially, Oops, this is not lined well. We need to have some smart contract templates to deal with to have some kind of assistance to do the bidirectional conversion. Okay, and I'll go to the detail on this, but you can look at this. The latest things we're working on is called a decentralized media rights application format. Essentially, it's like any other MPEG application format. We're going to put a number of MPEG technology and non-MPEG technology together to make a application format, and then that will support interoperable decentralized music and video applications. These are the things that we start with, but definitely we can extend that to other type of media content. That, for example, the MPEG technology, we have identified the interactive music application format, dash for streaming, the contract for governing agreement. We do have a number of example or use cases to specify what kind of contracts that we use. And then we have many other non-MPEG technologies that we need to rely on to form this. This is ongoing. We started. We have not come to a working draft yet. We're still in the stage to gather requirements, our use case requirements, collect the information. And so, all right. So for me, I would like to just quickly get some point, wrap this up, and so we can have a demo. A lot of things that can be learned from a development MPEG standards. And personally, I feel that nowadays we're dealing with the Metaverse related standards, interoperability, and a lot of things that we can borrow from the development, the experience of developing MPEG standards. Things like, I was so curious, maybe this like a Metaverse edition of MPEG 21 all over again, but now MPEG itself, it probably is not going to be going to have this capability to work on all the things. Definitely, we need a collaboration of multiple STOs to that. The things that have been changed, as I said, the content format, encoding, encapsulation, distribution, all things are different from the previous simple conventional video audio. The user, because become more complicated. Maybe we have digital twin room avatars and so on. Okay, the terminals, the user devices will be different. The services could be decentralized, engaged, age, or even tethered. For example, the glass can be served by a phone, right? And so on. The territories probably have a different jurisdiction, regions that give you different rules for governing those jurisdictions. Okay, and so on. The actions, entity protections, they are can be all different because of the complexity and the content, the things that we're going to deal with, digital assets, or we're going to deal with, the governing their usage will be probably be more complicated. Whether or not we need to have a number of use cases to talk about, what kind of license that we can deal with, because we now will have to deal with not just a consumption, because the usage will probably involve interactions as well, and how we're going to deal with that kind of thing. But the transaction agreement and that need to be worked on as well. Okay, in terms of contracts. Okay. And hopefully, on this side, we have, identified topics from this working group, and we can do some alignment and see which one. So, in what directions we're going to talk about. Okay. With this, I like to hand over to Sasha Mitchell for a demo from Elacity on the blockchain-based multimedia platform for content distribution. Hopefully, he has enough time. Sasha?
Hey, Xin.
Okay.
Thank you.
Let me quit from here. Stop sharing. All right, it's yours.
Brilliant. Thank you. If I can share my... Okay. Can you see my screen okay?
Not yet.
Okay. How
Oh,
about now?
It's coming up. Yep, there it is.
Fantastic.
It's up.
Okay, well, thank you everyone for having me here today. It's an absolute pleasure to get to present all the work that we've been doing, and a huge thanks to Dr. Xin Wang for all his contributions, because as he mentioned, he talked about CEL, content expression language, rights expression language, and MCO, and this is all technology which we've been incorporating our side to ensure that we can meet a standard both for traditional legacy systems, but also for the kind of where we're moving in a user-owned metaverse. So Elacity is a decentralized multimedia platform for distributing user-owned content. And our platform is designed to empower creators in a user-centric access economy, where we enable creators to protect and distribute their intellectual property globally into the metaverse and enjoy new revenue streams by combining blockchain governance with digital rights management. So really our core goal is to make data monetization equitable and inclusive for all. And we operate using Ethereum virtual machines. So the goal is here that we want to make this as interoperable and user-friendly as possible with all these different ecosystems. So our key features is that we encrypt assets into digital capsules, and then we let users issue smart contracts with NFT access tokens. And within those access tokens, there are specific DRM rights embedded, which enable a user, a consumer, to fetch the license key to decrypt that content. So in this demo today, I'm going to be showcasing a video capsule. We're going to create a video capsule. We'll issue some NFT access tokens, and then we'll show how a user can purchase these on an open market. They can decrypt the content, but not only that, with each purchase, royalties are distributed to the stakeholders that we define in the contract, and the user is also able to resell that access token with a set royalty percentage themselves, which they can earn. So thank you, and let's jump in. So here is Elacity, and we're in the portal. We facilitate decentralized identities. So the idea is that everyone owns their own identity, which is quite the fundamental difference to what we have today in the kind of Web 2 ecosystem. So we have our cinema district, and here we're going to go through the process of minting a DRM protected NFT asset. So we can imagine capsules for all kinds of different assets in the metaverse, and today we'll be looking at video. So everything that we're doing today is uploading to IPFS, which is the interplanetary file storage system, which is essentially a distributed file sharing system. So we can see here as we go through the contract, we can define whether you're an independent creator, you're a group, or you're a content distributor. In this case, I'll be an independent creator. We can define the rights in which we want the asset to actually be accessed. So it could be free, meaning no access token, buy once, play always, meaning the user can buy an access token and enjoy the content, but they can't resell the access token, or buy once and be able to always enjoy it, but also be able to resell the access token, and we'll define set amounts. Future rights we can imagine is pay-per-view and rental as well. So we're going to go for the ability to resell. We're on the Elastos smart chain, which is an EVM compatible smart chain. It's less than a cent for a fee. We're in the test net right now. And so we'll go and set a price for the asset. And then here we can choose who we want to distribute royalties to. So we have, multiple different stakeholders you can imagine, and you can set as many as you like. So in this case, got some addresses here that we can set up. So the creator might agree that they have 60%. We might have another creator who's getting 10%. Then maybe have the publisher, 10%. The distributor. %. And then finally, the investor. 10%. So we make up 100%, and these are the addresses in which, when every purchase of an access token is made, the percentages that have been defined here will be distributed to these wallets. Today, royalty collection and distribution is very centralized, and it's usually done on a quarterly basis, and it's done on estimates, so it's not clearly defined. When we bring it into blockchain law and we go under blockchain governance, we can ensure that with every transaction, payments are streamed to everyone's wallets immediately. So it completely increases efficiency, but also cuts down operational costs, meaning the creator can get more in this metaverse environment than they can in the current one. So here we're going to, because we're enabling access token holders to resell, we can define how much they can earn from that sale. So we can move the bar to however we're comfortable with, and the remaining percentage will be distributed in the allocations that we've also set. So in this case, let's set 50% for the reseller. So we'll set a thumbnail. Yeah, the size a little bit too. So here's a nice NFT thumbnail. Continue, and then title of the asset. Ability to set tags, and this will all be in the metadata. Metaverse. Future information. And so how many access tokens? We can set the scarcity. So these are essentially the keys in which decrypt the content. In this case, let's set 10,000. In this way, we can define scarcity of access. And it doesn't matter how many we issue, they're ERC 1155 tokens. So it can be 10,000, or the population's worth, say, 8 billion, and it will all be processed in the same transaction. So here we have an overview page where we can see all the information on the asset that we're going to be minting. Right now, it's just we need to wait for it to generate the ISCC. This is the process in which the data is being encrypted, and then we will go through the process of converting what is CEL and REL contracts into EVM smart contracts and deploying them onto the blockchain. So this is ready. We can go through the process. And so really, I mean, what we want to offer users globally is not only borderless transactions around the world, but the ability to have flexible business models. The Web3 space, particularly today, is very reliant on tokens and issuing tokens to be speculated on, but not necessarily bringing in business models on how to actually monetize content. So there's a lot of speculation, but in this environment, we can introduce different business models such as pay-per-view, buy now and resell, and even go into free models where users can actually do advertisement deals as well. So if you're issuing your data for free on IPFS, maybe you've got verifiable credentials, and you've done certain reputation requirements to enable you to now interact with advertisers as well and earn revenue that way. So we really want to legitimize the space from what feels quite wild west today into something which actually brings a lot of efficiency in how automation and operation takes place, with the added benefits of security and digital rights management. So we've now gone through the process. The NFT video capsule has been minted. We can see here, we have the ability to review what we've done. I currently have all the access tokens and they're for sale on the marketplace. We built a technology called Capsule Connect, which enables a user to fetch the license key directly from the blockchain. So when we look at legacy DRM today, it's done through central servers issued by central parties. Now we can say it's actually been decentralized and is able to be fetched if you have an access token from the blockchain using a private function. So we use WebAssembly WASM technology to ensure this happens. So in an instance, we fetched the license key to decrypt, and we have the ability to now play back.
I've always lived in a smart world.
I have the access tokens here. I'm selling all 10,000 right now. And so if we now go and switch users, we can, so let's be a new buyer. Okay, so as a completely new wallet coming to the marketplace, you can see it's got a padlock on it. I'm unable to play the video, it's encrypted. And the only way for me to decrypt and play this video is to actually own an access token. So I can see I can purchase 1-for-1 ELA. I can see the distribution rights and how it gets paid out. I can choose how many I'd like to purchase, because maybe I'm a re-ticket seller, like a ticket tout. I might want to see the scarcity, see the percentage in which I can earn on resales, and then buy up tickets to resell as well, knowing that I can earn a profit from that too. And the scarcity of access tokens introduces new economic models, which is really interesting. So I'm going to buy an access token now. When you think about Amazon and kind of big players today, when you purchase a movie online or buy some music, you don't have the ability to resell it like you can a physical good today. Like we can rely on whether it's marketplace or eBay to resell goods, and we don't have that online today. So when we introduce DRM and this new technologies to create scarcity of access with contracts which ensure that the access is protected, we can then start to trade that access, and we can all be included in this environment. So we can see here, I've just purchased the ticket, the access token, I've decrypted the content, and now as a new person, I can now watch it back. I can sell that access, and with that, I can also see that I'm included as the 50% now as well, and the remaining people. So with that, with this access token for sale, as a buyer, I can also now see that there are multiple individuals who are selling access tokens to this media too. So I could pick who I want to do business with. And ultimately here, we've introduced this new economic model into the Web3 environment, where everything is governed by blockchain technology, and this can be introduced into the metaverse, and we can imagine it being used in a diverse range of applications and assets, not just including video, but how we encrypt music, how we encrypt even 3D assets, how we encrypt metaverse worlds, our avatars. There's, it goes so vast, and DRM, we're almost entering this new wave where we saw DRM and the golden age it brought to Web 2 and content distribution and monetization, and now we're starting to see it emerge into the smart contract space, which in its pure form is about empowering individuals to do more and to control their content, and then to be able to monetize it. So one of the last things I'll just show is, so I've now just listed our access token for sale. We can see there's 2 vendors, they're both available. And when I look at, which I can't do as this seller actually, but if I was to be a new seller and look at the others, I'd see that the distribution is slightly different. And then finally, those addresses in which we put out, you can see here, this was the main address which received 50%, but then we had the others with 10%, which in this case is 0.1. The creator received their 10% for the sale I've just done, the publisher another 10%, distributor their 10%, investor their 10%. So everyone in this process just got streamed income. And if we were to take this a step further, the royalties in which we've assigned here are actually tokenized too. And so we could go a step further and envision a marketplace for actual royalties themselves. So users can actually participate in trading royalties, but that's probably a step further ahead at this point. And we need to ensure proper KYC and due diligence is done for that environment. But yeah, thank you so much. I mean, this is the general showcase of what we've built. It's an absolute pleasure to get to present it here. And I hope it excites everyone as much as it's exciting us. And it's certainly a rabbit hole which just continues to get deeper and more exciting as time goes on. If anyone has any questions or they'd like to reach out, please do. Otherwise, we have a live NFT platform today at ela.city. And also there's a documentation which I'll put in the comments if you'd like just to read more about us and learn about what we kind of have in the big vision here. Thank you very much.